In this video, we're going to talk about the difference between continuous data and discrete data. Now, continuous data is data that can take on any value in an interval, whereas discrete data, it can only have specific values. So let me give an example. So let's say we have the interval 1 to 10, or we can write it this way. Let's say that x is a value between 1 and 10. Now, in a continuous set of data, x could be 1, it could be 1.3, it could be 2.46, it could be 5.389, it could be any value between 1 and 10. Now on the right side, when dealing with a discrete set of data, x can only have specific values. For example, it may only have values that are whole numbers, such as 1, 2, 3, 4, 5, and so forth. So here it only has specific values, not values like 3.46 or 4.785. Now, continuous data is data that can be measured. So if you're measuring something, it's not only going to be whole numbers, it can be decimal numbers or fractions. Discrete data is data that is counted, and it's very easy to count whole numbers and natural numbers. So a good example of continuous data would be, let's say, temperature, because you can measure the temperature on any given day. For instance, today it might be 83.6 degrees Fahrenheit, or tomorrow, let's say in the desert, it might be 99.46 degrees Fahrenheit. So this is something that can be measured. On the right side, let's say if you're rolling a 6-sided die, the only numbers that you can get are discrete values, 1, 2, 3, 4, 5, or 6. If you roll a 6-sided die, you can't get 2.37 or 4.6 because it can only take on specific values. And so that's a very simple way to distinguish continuous data from discrete data. Now, what we're going to do is go over some examples. So for each of these situations, would you say it represents a continuous set of data or a discrete set of data? Let's start with number 1, the speed of a car. Would that be continuous or discrete? Now, the speed of a car, would you say it can be measured or counted? The speed of a car can be measured. A car could be going at 25.6 miles per hour. It could be going at 30 miles per hour, or it could be going at 42.86 miles per hour. And so it doesn't have to take on specific values. It can be any value. Therefore, the speed of a car would represent a continuous set of data. Now, what about number 2, the number of cats in a neighborhood? Can that be measured or counted? In this case, you can count the number of cats in a neighborhood. In your neighborhood, you might be able to count 5 cats, or 12, or 18. You can't really have half a cat. I mean, that would just be wrong. So this set of data can only have whole numbers. In this case, this would be a discrete set of data. Now, what about your body weight? Your body weight is something that you can measure. A person could be 160 pounds in weight, or they could be 173.4 pounds in weight. So that can vary. It doesn't have to be specific values. It could be any value. So that would be C for continuous. The number of doctors in a town. You can't have half a doctor or a quarter of a doctor. You can have like 8 doctors in a town, 12 doctors in a town, 17 doctors in a town. So this would be discrete. Now, what about the number of books on a shelf? That can be counted as well. So therefore, that represents a discrete set of data. Now, the height of a student. You can't really count the height of a student, but you can measure it. A student might be 6.3 feet tall. They could be 5.84 feet tall. So that can be measured. So we're going to say C for continuous. The number of students in a classroom, that can be counted, like the number of doctors in a town. So that's going to be discrete. Now, what about number 8 and 9? Because both of these problems deal with your age. Feel free to pause the video and work on those two problems. When you're ready, you can unpause it to see the answer. So let's start with number 8, your age rounded to the nearest whole number. So what we're going to do is we're going to list the ages of, let's say, a few different folks. Let's say John's age rounded to the nearest whole number is 16. Let's say Lucy is 19. Let's say James, when you round his age, it's 22. And Jared will say 24. So because it's rounded to the nearest whole number, you can't have any numbers in between. You can't have 16.8 or 19.3 or nothing like that. So therefore, these values or this set of data can only take on specific values, that is whole numbers, which means we have a discrete set of data. Now for number 9, this is your exact age. So John might be 16.2. The next person might be 19.3. And then the third person might be 21.76. The last one might be 23.958 years old, if you want to get the exact age. In this case, that can be measured, not counted. So this would be a continuous set of data. Now the next thing we're going to talk about are graphs, because you need to be able to distinguish if a graph is continuous or if it represents a discrete set of data. So I'm going to draw a few pictures. And as I draw these graphs, go ahead and pause the video, or while I draw, just determine if it represents a continuous set of data or a discrete set of data. Okay, so looking at the first one on the top left, would you say it's continuous or discrete? For it to be continuous, there can't be no discontinuities, no jumps in the graphs. Basically, it's going to be a straight line. Well, not necessarily a straight line, but a connected line. All the data in this graph is connected, so this would be continuous. The second example will be discrete. You can easily tell it because the points are not connected. You see a lot of discrete values. If you see individual points that are not connected, it's going to be discrete. So these three types of graphs they represent discrete forms of data. Whereas if you have a smooth line, it would represent a continuous set of data. And so that's a quick and simple way to distinguish whether a graph represents a continuous set of data or a discrete set of data. So that's basically it for this video. Thanks for watching.